You act like you're
Dying. Okay.
Okay, you know, maybe I should have just stayed in bed. Didn't know I was gonna get
Say
attacked.
what's the problem.
Oh.
You want that pencil?
You know what? I mean,
I'll throw it a little more aggressively today. Especially if you destroyed my gift yesterday.
you put it back.
I have memorized.
It was still not correct. I was missing pieces still.
I ate them.
I wouldn't be surprised.
Did you and Gabe ever like play against each other? Like you said you
Tennis?
yeah.
Oh,
No.
I beat them. Yeah.
Oh, we did that last week. I also don't know if I'll have a racket Friday, so
And if you tell, that's fine.
I should, but because mine's getting restrung and I don't know my stuff can be able to get me wrong.
Okay, so what we're going to talk about today is geometric sequences. So this is a sequence A1 through AN and beyond, where A of 1 cannot be 0. And it also has a real number R, which is also not 0, such that my current term is just my previous term multiplied by that R. So there's a very specific name for R. In an arithmetic sequence, we called our common difference D. In a geometric in a geometric sequence, our common difference is called our common ratio, and we use R to represent it. So R here is my current term divided by my last term, or A2 over A1, A3 over A2, any term divided by the term that came before it. And this is called our common ratio. It is just like the common difference from the arithmetic, except it's a ratio, so it's multiplied in instead of added
Please tell me that's good.
in.
That's the whole. How many pages is this one? 4?
How much are we doing? We'll just do half it today. I'm planning this to be a lesson as well. So let's just do an example of what a geometric sequence could look like. So the first one I have is 6, -12, 24, -48, and so on. Just like the previous sequences that we looked at, these geometric sequences are considered infinite because they continue indefinitely without stopping. We have no idea what the end term is. Also, like the previous examples, we have to have a common change from term to term. So the change has to be consistent from term 1 to term 2, from term 2 to term 3, term 3 to term 4, and so on. So just like the previous one, if we're testing to find a common ratio, we should test at least 3 sets of consecutive terms. So on this particular example, I can just eyeball what my common ratio change is. How am I changing from term 1 to term 2? Multiplying by -2. So my common ratio is negative whole number 2. How am I changing from term 2 to term 3? Multiplying by -2. If you want to put an X in front to indicate multiplication, you can do that. Just remember, anytime we have a geometric sequence with a common ratio, it's always multiplication or division. And then I also noticed from 3 to 4 that I'm again multiplying by -2. So my common ratio holds for that sequence. Do we see the difference between an arithmetic sequence and a geometric sequence? Arithmetic is addition or subtraction from term to term. Geometric is multiplication or division. So of course, I'm going to show you a division example as well. So another example of a geometric sequence is 9, 3, 1/3, 1/9, and so on. When we talk about a common ratio of division, we can't just say it divides by 2. We have to indicate the division as a multiplication of a fraction. So what am I dividing by from term 1 to term 2 here? 3, which is the same as multiplying by a positive 1/3. So we indicate division as a multiplication of a fraction.
Definitely skip it.
I did. I skipped 1. There we go. And then from term 2 to term 3, same thing. I still multiply by 1/3, which is the same as dividing by 3. And then from term 3 to term 4, same thing. So each time I'm dividing by 3, which is the same as multiplying by 1/3. That is the biggest mistake I see happen a lot, is that kids will say dividing by 3, and they'll use the whole number 3 as a ratio instead of the fraction 1/3. Everyone okay so far?
So really everything's multiplication.
Everything's multiplication, yes. Okay, so let's go ahead and write out what the formula for an nth term of a geometric sequence is, and then we'll use that. The formula for the nth term of a geometric sequence is different than the formula for the nth term for an arithmetic sequence. It is a of n equals my first term a of 1 times my common ratio r to the n minus 1 power. Of course, we have a lovely example to go with this one. So this example tells me it's a geometric sequence, which means that I know when I find the common ratio, it holds true for every set of consecutive terms in the sequence. It tells me that this sequence has a first term of 3 and a common ratio of -1/2. It asks me then to find the first 5 terms and the 10th term of the given sequence. So I'm going to do this the formal way, but honestly, once you realize the pattern, you don't have to write out how we find each term. You just write what the terms are. But to show you what's happening, I'm going to write it out formally and kind of like expanded. And then you're welcome to do whatever you're comfortable with on your paper. So clearly, I know that my first term is what? 3. So A1 here equals 3. How then am I going to find A2 or term number 2?
Look at the numbers now.
I'm gonna take my first term 3 and I'm gonna multiply it by my common ratio of -1/2. Right?
Don't you have to do the n minus?
We don't, you can. It's not gonna change anything
Why?
because I already know what my first term was, so why would I go through the whole nth term formula when I can just say first term times -1/2? Which is the same thing because it's the first term times my ratio to the 2 minus 1 power, which is just 1.
Oh,
It's the same thing.
okay.
So then I multiply those together and I get what as my second term? What's -3/2? Thank you. Then for my third term, I could do the nth term formula, or I could just take the previous term and multiply it again by my common ratio of -1/2. And when I do, I get what as my third term? +3/4. And then I just keep going by multiplying my previous term by my common ratio.
Wait.
What?
So why does the n minus 1 thing not matter?
Because I'm not finding a random term in the sequence, I'm building off the previous term. You can continue to use that if you choose to.
You're forgetting the square. Or the
I don't know.
Maybe not.
Okay, okay. We got this. This is good. First term times my common ratio, -1/2 to the 1 power, right? Still gives me -3/2.
Yeah.
If I were to do the nth term formula here, again, it would be my first term times my common ratio to 3 minus 1, which is 2, which is the same as using my previous term and just multiplying it by my common ratio. No different than if I had an arithmetic sequence and I knew that it added 5 each time. To find term 2, I would just take term 1 and add 5 to it. To find term 3, I would just take the previous term and add 5 to it.
I wasn't doing 3.
You can do it either way. It's going to work out the same. So this one, I'm still going to get positive 1/4. And when I multiply it by 3, I'm still going to get positive 3/4. If you want to continue to use that nth term formula, you absolutely can. Because it will still work every single time. But you don't necessarily have to if we're doing consecutive terms in a sequence. Because I can just say that it's building by my common ratio, and then I can multiply it out. It is entirely your choice. Either way, we're going to end up with 3, negative 3/2, positive 3/4, negative 3/8, and positive 3/16 as our first 5 terms, regardless of how you chose to do it. Does everybody see how we found those first 5 terms? You could have chose to do the nth term rule, or you could have just multiplied the previous term by the common ratio. Either way, it'll work out. Everybody okay with those first 5? Okay, now we have to use the nth term formula for my 10th term because I don't know any of my terms between 5 and 10. If I knew my 8th and my 9th term, I wouldn't necessarily have to. But because I don't, I have to use that nth term here. So my nth term rule is my first term A1 times my common ratio R to the n minus 1 power. Since I'm looking for A of 10, this is equal to A of 1, which is 3, times my common difference of negative 1/2, common ratio of negative 1/2, to the 10 minus 1, which is the 9th power. If you're doing it in a calculator, I would do this part first, and then multiply your answer by 3. And you should get negative 3 over 512. I have no idea what the decimal is, but I can tell you if you got that, but we don't write decimals. Questions, concerns, or issues? Did we all get negative 3 over 512?
I'm just gonna trust your.
You shouldn't.
I know, I should. In this case, it's all payback. No, stop.
Okay. Questions, concerns, or issues thus far? Are we all okay with the difference between an arithmetic and a geometric sequence? That's a wonderful question for me to ask on like a quiz or test. Yeah. Okay.
How many pages left do we have?
Well, we're only going to do one more side today.
So like, are we on that side yet?
Yeah, we're starting it right now. So let's do another example. So this particular example tells me that the third term of my geometric sequence is 5, and the 6th term is negative 40. It then asks me to identify the first and the 8th terms of this respective sequence. So I already know it's geometric, so once I find my common ratio, I can deduce that that applies to every set of consecutive terms in the sequence. And I just need to find the common ratio and find my first term, and I can find what it's asking me for, right? Anybody have an idea of how we're gonna do this? What do you mean by set them equal to each other? Okay, so do the nth term formula for the third term and the sixth term, because that's what it gave me. Then I will isolate one of my respective unknowns, probably the A1, and then set them equal to each other and solve for my common ratio R, correct? We all okay with that? So let's do that. I'm gonna start with my third term because I like to move consecutively. So A3 here, I know that my third term is 5, and that is equal to my first term A1 times my common ratio R to the 5 minus 1, which is the fourth, 3 minus 1, which is the second power. It's not my day. Which means if I wanted to isolate A1 here, what would I have to do to that R to the second power? Divide it over. So then isolating A1, this becomes A1 equals 5 over R squared. We will do the same thing with A6. Does somebody have a question? Sorry. Okay. We will do the same thing with A6 because that was the second term that I was given. I know A6 equals negative 40, and that is again equal to A1 times my common ratio R to the 6 minus 1, which is the fifth power. My goal again is to isolate A1. So what do I need to do? Divide the R5 over. And when I do, I get A1 equals negative 40 over R5. Now that I have both of these isolated for the same unknown, I'm going to set them equal to each other. When I do, I get 5 over R squared equals negative 40 over R to the fifth. And now I'm kind of stuck. What am I solving for in this problem? R. So logically, I need to get all of my R's on one side of the equal sign and all of my other numbers on the other side of the equal sign. Correct? Yeah. Logically, I also know that I have two R's with two different exponents. So ideally, I would like the largest exponent to be in the numerator. So which one of these R's am I going to move? The R5. How am I going to move it? Multiply it up to the other side. When I do, I get R5 times 5 over R squared equals negative 40. Then what do I do? Hold on, give me a second. But yes, we are going to do that. What do I want to move first before I start simplifying? The 5. Remember, I want all the R's on one side. I want all the other numbers on the other side. How am I going to move that 5? Divide it from both sides. I can then reduce, and I get R5 over R2 equals negative 8, because negative 40 divided by 5 is negative 8, right? Okay, questions, concerns, or issues thus far? We're not finished, of course, but I wanted to save this step for last because it's probably the least familiar to us. We did it, it's just probably been a while. So what I notice happening on the left-hand side is that I have the same base with different exponents, one in the numerator, one in the denominator. How do I combine an exponential term that has the same base but is in two parts of the fraction? We subtract, but the biggest one stays and we move the other one. So which one is the bigger one here, R5 or R2? R5. So this one stays, and I subtract the 2 that was present in my denominator, which is why I wanted the bigger one on top. Otherwise, I'd have to move some more stuff. I reduce this, so R to the 5 minus 2 is the same as R3 equals negative 8. And then I can easily solve R from here. How do I get R by itself without that exponent 3? Cube root. Can I take the cube root of a negative number? Yes. Any odd exponent can be done on a negative term because -2 times -2 times -2 does equal -8. So my R here is -2. How do we feel about that one? You also could have plugged that into your calculator and it would have worked out.
Wait, so what'd you say, any odd X?
Any odd root can be taken on a negative term inside. So I could have taken the 5th root of -32. I could have taken the 7th root of something like, I don't even know, -128, whatever. Any odd radical can be done with a negative inside. Any even, it gets a little fishy. Specifically, square roots, you absolutely cannot do it. 4th roots, 6th roots, they kind of follow a different set of rules. But any odd root can be taken on a negative value inside. Questions, concerns, or issues so far? Are we all good on how I got R equals -2? Now what do I do with that, Cody?
What do you make?
Plug it back into what?
What is that?
I don't know, we'll see. Which one? Sorry, honey.
Term equation?
Which end term equation? Because I had 2 happening. Doesn't matter which one. No, and I'm probably going to plug it into the version that already has A1 isolated since that's what I'll be solving for. So I'm just going to go ahead and plug it into the bottom one because it looks like fun. And when I do,
Fun.
I get A1 equals -40 over -2 to the 5th power. And I can plug that into my calculator. You will get a fraction. So we must then reduce our fraction.
These calculators also turn into that.
You should be able to find a fraction using it. That should be what? -32. Yeah, it should be -32 when I do -2 to the 5th. So I get -40 over -32, which reduces 5 over 4, because I can pull a -8 out of both of them. So my first term, A1, is 5/4. Questions, concerns, or issues with that one? Am I finished with the problem? No. What do I still need to find? My 8th term. How in the world am I going to do that? Nth term formula, and then I'll just plug 8 in for n. So I found one of the things it was asking for. So I know A1 equals 5/4. Now I need my nth term formula, which tells me I take my first term times my common ratio to the n-1 power. I'm looking for the 8th term, so I'm going to plug 8 in for n's. And I get A8 equals 5/4 times -2 to the 8-1, which is 7 power. And it will come out to a nice, beautiful whole number. Let's see. Everybody else get -160. Questions, concerns, or issues on that? Anybody confused on how we did that? Are we good so far? Molly, stop drinking an energy drink.
Just coffee.
It is, but it's double charged.
Don't.
She's not. Okay, we're gonna do one more thing, and then I'm going to turn you loose for the day.
Yeah.
Like,
Right.
you see what it is? A giant green.
The thing that we're doing?
No.
Huh?
Oh,
Oh.
no. There's a lot.
Oh, it's a fish. It's the thing that they drew over my, it's a good day to do math.
Can you
Oh,
just
just keeps
erase
being
it?
added to them. I like that. Yeah.
Can you erase it?
Well, yeah, I'm pretty sure I can.
Would it erase the?
Lagging.
I know, I think it's broken. Yeah, I don't know, I'm gonna have to sleep over right now.
Already broken.
So let's go ahead and do the last little piece of the notes, and then we're finished for the day.
Little piece.
Yes,
Like, you're gonna take as much space as that one?
we're literally just doing the formula and one example.
I will definitely put this in the next page.
Okay, so just like on the previous arithmetic sequences notes, after we went ahead and practiced with the A and term formula, we also looked at the partial sum formula. So that's what we're going to do here as well. Again, that is denoted by S of n, where n indicates the number of terms that I'm adding together from the sequence. It's considered a partial sum because I'm not adding all of the terms together. So there is a very specific formula that we have for the partial sum of a geometric sequence, and that is S of n is equal to my first term a1 times the fraction 1 minus r to the n over 1 minus r. That's it. That's your formula. Like, we're not done, but we're going to do the same thing. But that's the formula that we're going to use. You should definitely note in your notes that this is the partial sum for a geometric sequence, because we're also going to be doing infinite sums tomorrow. So make sure that you know the difference when you look at them. Partial sum uses S, infinite sum will use something else. Okay, so the example I would like to do for partial sums of a geometric sequence says that we have a sequence. The sequence is given to us in decimals, which means the rest of the computation for us is fine as well. And my sequence is 1, 0.3, 0.09, 0.027, and so on. We know it's a geometric sequence, so my common ratio will hold consistent throughout the whole thing. And it asks us then to find the sum of the first 5 terms. Since this is a partial sum, I know I'm using the previous example, or not the previous example, the previous formula. So what 2 pieces of information do I have to know in order to use that partial sum formula?
The change.
The change, so my common ratio R. What else?
Like the A1.
And my first term A1. Do I have any of that information given to me point blank?
The A1.
I have A1. So I know that my first term is equal to what?
1.
1. Awesome. So the only thing I need to find is my common ratio R. How do we find the common ratio of a geometric sequence?
Just divide by 3.
What do you mean by difference between terms? Okay, so how do I find that without just guessing or eyeballing it? How do I mathematically find a common ratio? I take a term and divide it by the term that came before it, right? So my common ratio, we're going to use A2 and A1. So my ratio R is equal to A2 divided by A1. You could have used any consecutive set of terms, so you could have used A4 and A3 or A3 and A, which is your choice. At A2 here is 0.3, A1 is 1, which means my common ratio is 0. Or 3/10. We're going to leave it decimal though, since I am pretty sure I'm going to get a decimal. So now I have enough information to go ahead and fill in my formula. And how many terms am I adding together? 5. So every n in this partial sum formula is going to be a 5.
I have a question.
Yes.
In partial sums,
Mhm.
why can't you just, like, if you're adding all the terms together, right? Why do you add 2 terms and then add that? Actually, why can't you just find the 5th term and just add them all together?
You absolutely could, but a lot of times when we're doing a partial sum, it's more than 5 terms. So it's kind of a hassle to write out all of the 10 terms or what they are and then add them together also. You absolutely can, but it also should be noticed that a geometric sequence can grow or decrease very, very quickly. So adding them together, if you round, will kind of throw all of your numbers off as well. So that's another thing you should be concerned about. But you absolutely could just find the n terms that it's asking for and then add them together on your own. That usually will take longer than just using this formula. Okay, so S of n here equals my first term, which is 1, times 1 minus my ratio 0.3 to the 5th power, because it's my nth power, over 1 minus my ratio 0.3. If you're putting this into a calculator, I highly suggest you parenthesize your numerator and parenthesize your denominator. I also suggest you don't do it all at once, but that's up to you. And you will get a decimal as your answer on this one. Abe, I think you were thinking about the partial sum sequence. So it sounded like. And you should get 1.4251.
I did not.
Not good. I don't have my calculator. Just call it. No, get to work. Did anybody get 1.4251?
Yeah, I did.
Okay. If you're not getting it, check to see what all you're applying that 5th exponent to, and then make sure everything is grouped appropriately.
I got it.
Okay. Anybody super confused by anything we've done today? Are we okay? Who thinks this is pretty easy? Couple of you. Oh, you're home. Now go ahead and finish up the note.
Say that. Yes. You must.
Also, just we're gonna do it